Okay, so that was about your basic condition beta. If you are not starting from origin, the displacement is given by the formula y is equals to a into sine omega t plus phi, and velocity will be a omega into cos omega t plus phi, and acceleration will be minus of omega square a into sine omega t plus of your phi. If you are not starting from origin, if I have written already that one, yeah. So if you are not starting from your origin particulation, if the particle is not starting from origin, so what is the displacement, what is the velocity, and what is the acceleration? This omega t plus phi is known as of your phase angle. This omega t plus phi is known as
Yes,
of what for me? Phase angle. Now let us try
phase
to
angle.
talk about your phase very detailedly. What do you mean by your phase? See this one. See, I told you the the quantity, the quantity omega t plus phi, omega t plus phi is called phase, is called phase, or also called as phase angle. The phase actually gives me the status of the particle beta. Ante kada. So this phi value will give me the status of the particle. If phi value is 0, will say that
Yes,
the
sir.
particle is origin. If phi particle is not at origin, that means this will give me the position where it is from, actually from the original position
Origin.
particulation. So I
Yes.
can say that phase gives me, phase gives status of your particle, gives the status of particle. That means its position and direction of motion, its position and your direction of your motion at any point, at any point. Okay, so phase will give me what beta? Status of the particle. Status of the particle means its motion of the particle and also its direction, and
Right.
also its direction particulation. Now for time being, I am representing this phase as by the formula of dow, that is equals to omega t plus of your phi. Okay, in some books we also represent it by phi naught beta. That's not a problem. You can even represent that one by that given condition, no problem, isn't it? So this dow is known as of what beta? Phase. Dow is equals to omega t plus of your phi. Okay, now see here, if at any time, say for example, if at any time, phase is equals to 0, that is x will be equal to how much beta? X will be equal to a into sine omega t plus of your phi, that is equals to 0. Okay, so what do you mean by that one beta? If the phase value is becoming for me 0, this total value, sine 0 will be equal to how much for me?
0, sir.
This value is how much for me? 0 only, na? So x value will become
Yes.
for me how much? 0. What will be the velocity?
Yes.
V is equals to your a omega into your cos of your omega t plus of your phi. This total value
Yes.
is 0. So V value will
Yes, sir.
become how
Means
much?
1.
V is equals to A omega
Yes,
1.
sir.
Na? That
Because
means
cos. Yes, sir.
the
Cos 0
particle is
omega.
at your origin and going towards your positive direction. So velocity is
Yes.
not 0. C. When it is your phase value
Yes,
is
sir.
0, velocity is how much for me? A into omega. That means the particle is at your origin. So I can say right now when V is equals to your A omega particulation. So I can say that the particle is at your origin. The particle is at origin. The particle is at your origin and going towards positive direction, because velocity we got positive, no, towards your positive direction. Clear? Is it
Yes, sir.
clear? Let me draw the
Yes.
diagram. Let me draw the diagram for this one. Yeah, this is a particle which is making a linear SHM. Okay, we are talking about only the linear SHM right now here. So this is also one position right now, and this is your one position. I'll take the first situation. Here, this is your particle. This is a mean position. This is your mean position. This is your extreme position. This is your left extreme position. If tau is equals to 0 for this situation. Okay. So where is the particle starting from? X value enta? 0 kada?
Yes, sir. Because it's starting from origin.
Velocity is going in which direction? Positive x direction. With what
Yes.
velocity? V is equals to your A into your omega.
Omega.
Then,
Yes, sir.
isn't it? In the same way, in the previous case particulation itself, here itself, if I am taking, if the value of your value, if you are writing here, if phase is, that is dou is equals to pi by 2. So at any time, if I'm taking dou is equals to 0, we got x is equals to 0 and velocity is equals to your A into your omega. Now, if I'm taking the phase value, dou is equals to pi by 2. Now, can you tell me what is the value of your x? This value, sine pi by 2. And then, this one is x
Sir,
into
pi
sine.
is 180, right, sir?
This one is, yeah, 180.
Pi
180
left
by 2
consider
means
is
90.
180.
So 180
Zero,
by
sir.
2 is 90. Sine 90.
0, sir. 1, sir.
Uh,
Sorry, 1.
1.
1, sir.
This
1,
will
sir.
be equal to 1. That means x will be equal to your how much right now for this relation if I am writing? X is equals to your A into your sine. This one is nothing but of your pi by 2. So sine 90. So 90 is 1. So it will be equal to A. That means x will be equal to your A.
Yes, sir.
Then what will be the value of velocity? V is equals to A into omega into cos 90. 180 by 2 is 90. Cos 90 is 0.
0,
So
sir.
velocity of the particle will become for me 0. Velocity of the particle will become for me 0. Is that clear?
Yes, sir.
Isn't it? That means there is no velocity of the particle. When I'm taking here tau is equals to pi by 2. So what is the x position of the particle beta? X is been right now. So if I'm taking this one as of your mean position, I'll take everything about this line only. Okay. Now here is the particle. This was your particle. So x was equal to how much beta? X was is equal to how much? Can you tell me where will be the x? See here. X will be at your extreme position.
Yes, sir.
That means the particle is not at the center. Where is that
Center.
particle? Can you tell me right now?
Extreme, sir.
Where is that
Left or
particle?
right?
That particle is actually this was your mean position right now. But now the particle when theta is when phase angle is
Sir,
90
positive,
degrees,
sir.
it is
Right.
positive
Right
extreme.
extreme.
Means the particle is somewhere here. So this will be your x. X will be equal to your A from here to here.
Yes, sir.
And velocity here is how much? 0.
0, sir.
The extreme position, the velocity is how much beta?
0, sir.
0. Clear?
Yes, sir.
So like that, I can go on take the values. If I take the tau value is equals to 180 degrees, tau value is equals to 180 degrees, then the x value will be equal to at origin and the velocity will be negative. It will be going in this direction. You can check with that one. Okay. I'll just write here right now. If phase value is equals to, if phase is tau is equals to 180. Dou is equals to how much beta? 180 degrees right now for me. So what is the value of your x? Can you tell me? X value is equals to your A into your sine 180. Sine 180 is
Yes.
sine
Sir,
180.
it's cos 180. Sir, it's 0 or 1, sir?
It's అట్లా చెప్తే ఎట్లా చెప్పు 0 1 అని నన్ను అడుగుతే నేను ఏం చెప్పను నీకు చెప్పు.
Sir, actually, I have to learn above 90, sir.
మరి నేర్చుకోవాలన్నా
Yes,
ఇంకెప్పటివరకు
sir.
చెప్పు ఇట్లే
Yes, sir.
ఇయర్ అయిపోవడానికి వస్తుంది. The same way, if I am taking velocity, v is equals to your A into your omega. Velocity formula in the A into your omega into your cos of your, this one is your 180. Cos 180
Minus 1.
minus 1. So it is minus of your A omega and this will become for me 0. That means the particle is at origin and velocity will be negative. So it is minus of your A into your omega. Okay.
Yes, sir.
The same way dou here. So dou value is equals to your, after pi if I'm writing 3 pi by over 2, that means 270 degrees. Again the particle will be equal to your how much? Where will be the particle? You need to tell me right now. Again when dou is equals to 2 pi. So where will be the particle? 2 pi means right now 360 degrees. 360 degrees
360
means
degrees.
sine will become for me how much? Sine 360 is nothing but 0. So velocity will
Okay.
become how much for me? Positive. That will be equal to 1. That means this will be the direction of the particle. That is nothing but A into your omega. Is it clear?
Yes.
So got an
Yes, sir.
idea, isn't it? So that is the way
Yes,
how
sir.
do we get the value of your phase for the given condition. So for the remaining two conditions, write the given condition. If phase is dou is equals to your how much this one 3 pi by your 2. So x is equals to your a into your sine. This one is your 3 pi by 2. So this value is equals to your how much? And the same way velocity v is equals to a omega into your cos of your 3 pi by your 2 part of relation. So that will be equal to your a into your omega positive, and this particle will be equal to how much for me?
270. Sorry.
370 kada. ఎంత వస్తుంది చూడు?
270.
270 degrees. The same way, one more I told you, if phase value is equals to your, if phase value is dou is equals to your 2 pi. So x is equals to your a into your sine of your 2 pi. So that will be equal to your how much? 0. And v is
0.
equals to your a omega into your cos of your 2 pi. Cos 360 is nothing but equal to 1. So this will be
Minus.
equal to your a
So
into
this is
your
360.
omega part of a relation. Is it clear?
Yes, sir. Yes, sir.
Isn't it? So that is the way how do we get the values for the given conditions part of relations. Whether you take it as a right now, see, I have taken only the values of your extreme conditions right now, beta. You can take the values of your like anything 60 degrees, 30 degrees, or maybe your 45 degrees part of relation. So depending upon the situation of an angle, you can tell me what is the phase angle for the given situations. Okay, na?
Okay, sir.
Got an idea?
Yes, sir.
Differentiation కూడా గుర్తుందా మర్చిపోయావా అది కూడా?
ఏంటి సార్?
Differentiation integration గుర్తుందా అది కూడా
ఎస్ సార్,
మర్చిపోయావా?
గుర్తుంది సార్. గుర్తుంది
పక్కా
సార్. ఎస్ సార్.
differentiation అన్ని
ఎస్ సార్.
గ్రాఫ్స్ కూడా చెప్పాను నేను నీకు చాలా నీట్గా అప్పుడు ఇక్కడ ఉన్నావో ఏమో అవరా.
ఎస్.
ఓకే, కాలేజీలో ఏం నడుస్తుంది?
సార్ ఇప్పుడు క్వశ్చన్స్ ఫేజ్ డిఫరెన్స్లోనే చేస్తున్నాం సార్ క్వశ్చన్.
ఓకే, సో యూఆర్ డూయింగ్ ద ప్రాబ్లమ్స్ ఆన్ యువర్ ఫేస్ డిఫరెన్సెస్.
ఎస్ సార్.
అది ఇంకో ట్రాక్లో ఏం నడుస్తుంది?
సార్ అంటే ఈ ఫుల్ వీక్ది అంటే కొంచెం క్వశ్చన్స్ ఎక్సర్సైజ్ చేపిస్తున్నారు సార్.
ఓకే. See this diagram better. Now, as the time increases, will the phase will increase or decrease better? Theta will increase అవుతుంది కదా?
సార్ ఇంక్రీస్.
Yeah,
Yes,
that will be
increase.
your increase. That you should be remembering this one. As time increases, as your time increases, phase dou is equals to your omega t plus of your phi. Dou is equals to omega t plus of your phi also increases, isn't it? So an increase of 2 pi brings to again same position kada nana. So if it is going from mean to your extreme, again extreme to your mean, again mean to extreme, then it will bring back to the original. So like, see, I have started from your what angle beta? Tau is equals to your 0 to your tau is equal to 2 pi. So it is going from your mean, then your extreme, then mean, then again your extreme position, then from extreme position again to your mean position. అవునా కదా? So I can say that right now,
Yes, sir.
an increase of 2 pi from where? 0 నుంచి 2 pi
Yes.
వరకు ఇంక్రీజ్ అయితే again the particle is bringing back the particle to what? Original position. Original ఎక్కడ స్టార్ట్ అయింది? Origin.
Yes.
Final కూడా we are coming
Yes.
it to your origin. So an increase of your 2 pi, brings to the same status. అవునా కదా? That means 0 kada status ఎంత? X is equals to 0, mean position. At angle 2 pi also the status is how much right now for me? 2 pi. and velocity is again
Yes.
from your positive part of relation. Is that clear?
Yes. Yes.
That means you can write here right now omega t plus phi, omega t plus phi at origin will be equal to omega t plus phi plus 2 pi. These two are same.
Yes, sir.
These two are same. Indukani, we are starting from your
Sir,
origin.
because origin,
Yeah.
yes, sir.
So
360
this one is the not from origin, so from somewhere initial position.
Z. Yes,
Omega
sir.
t is equals to 0 part of relation. And here
Zero.
also you are
Yes.
going from your increasing from where 0 to your 2 pi radians. So these two values will be your
Yes.
same for, isn't it? So if I'm writing the
Yes.
amplitude for displacement and as well as of your amplitude position, now tell me what will be the graph for this one. See, if I'm drawing the graph for your, this one is your amplitude versus your phase. So that will be your sine function. So the graph will be something like this. It will be increasing like this from mean. It will go to your extreme like this. Again from your mean to your extreme. So this will be equal to 0. Then again from this one like this. Go on, I can take like that, no problem. Okay. This is 0. This will be equal to your how much beta? Pi. And this will be equal to 2 pi. This will be equal to your how much right now again? 4 pi. Okay. So here it is your maximum. This one is nothing but of your plus a. And here it is nothing but of your minus a. Okay, again 2 pi, the particle
Yes.
is coming to mean position. See, at x is equals to 0, if phi value is 0, the x value is also 0. That means amplitude. As the value of the phi is becoming 180 degrees, then amplitude is becoming maximum. Then again
Yes.
270 degrees, amplitude is negative. Then again at your 360 degrees, then again the amplitude is becoming for
Zero.
me 0. అర్థమైందా గ్రాఫ్ ఇది amplitude versus
Yes, sir.
your phi. అర్థమైందా చెప్పండి మరోసారి.
Yes, sir. అర్థమైంది, sir.
Sorry. Now in the same way, if I'm taking the velocity graph, this is your phi and this is your velocity. Now tell me at x is equals to 0, that means at phi is equals to 0, this is a phi. When phi value is 0, what is the velocity beta? Is it 0?
Sir, it will be no, sir.
Not 0,
Yes, sir.
isn't it? Angle was 0, only the x was 0, but velocity was positive. Positive means it will
Yes,
be
sir.
having cos function. Velocity is positive means somewhere we will be having function like
Cos.
this.
Yes.
So cos function, it will be
Graph was
like this. The wave will be going like this. Got an idea?
yes, sir.
Uchinda? So that
Yes.
means you're starting from your 0. This value will be equal to having a maximum velocity v naught. And here also it is having a maximum value as of your v naught. This value will become how much beta for me? 2 pi. Then this
2
value
pi.
will become for me how much? 4 pi. Like
4
that.
pi.
Okay, na? So got an
Yes,
idea?
sir.
Graph between
Yes.
amplitude versus phase. This is your phase
That's
angle.
why, sir, that's why at pi we have got 0, right, sir, velocity.
Yeah. That is the reason at phi value is equals to 0. When phase angle is 0, velocity is maximum. When phase value is 0, sine value is also 0. That is x.
Yes, sir.
అంతే కదా, isn't it? See here, at x is equals to 0, amplitude is also 0.
Yes, sir.
And the velocity is positive. So that is the reason I have graphed right now. When phase value is 0, amplitude is positive, but velocity will be your maximum. Okay, na?
Yes, sir. Yes, sir.
Next side heading, phase constant. Next one is phase constant. See here, beta, the constant phi, whatever we have taken, the constant phi in the equation of your SHM is called phase constant. Is called what? Phase constant. Okay, phi value. Okay,
Yes,
this
sir.
phi is called as a what? Phase constant, or sometimes it is also called as of your epoch. It is also called as of your epoch, or also we call it as of your initial phase. It is also called as of your initial phase. Why? Now see here, in this equation, whatever the equation we have taken right now here, if I take t is equals 0 in this equation, what I'll be getting,
Yes.
beta? Y is equals to a into sine phi,
Yes, sir.
because this value is becoming 0, na? 0 plus
0.
anything
Yes.
will be equal to how much for me? That value only, na? That value is not going to
Yes, sir.
change, isn't it?
Yes,
So that
sir.
is the reason. If I'm taking t is equals 0 means what? Initial position only, na?
Yes, sir.
Isn't it? So that is the
A
reason.
sine.
But the another name for this one is what? The constant phi in the equation of an SHM is called what? We call it as the phase constant. We call it as either as of your epoch, or we are also calling it as of your what?
Initial
Initial
phase. Yes,
phase.
sir.
It is also called as of your initial phase. That means this will tell us or find out. This will enable us to find the position from where the time is being considered SHM. Like if t is 0, the particle is in equilibrium position and it is going towards what? Positive direction. Ante kada? If t is equals to 0
Yes,
in
sir.
this equation we got, if t is equals to your 0, the particle is where, beta? At your origin. That is nothing but
Origin.
equilibrium, and it is
Moving to
going in which direction? Positive
positive.
axis. At your positive
Yes.
x-axis particulation. It's okay. Let's say for example, I'm writing the condition. If at t is equals to 0, the particle is at equilibrium. The particle is at your equilibrium and going towards positive direction, and going towards positive direction and going towards your positive direction. Like see, x is equals to a into your sine omega t plus of your phi. This is our equation. Now if I take t is
Yes, sir.
equals to 0, at t is equals to your 0, the particle will be equal to where, beta? The particle will be equal
Sir,
to
it
your
will
how much
be
value? X is equals to
t
0
0.
only. X is equals to 0. At what
Means
position?
positive.
Yeah,
Positive
positive
x.
direction. Means x is equals to 0 at t is equals to 0. That means it is at your mean
Yes, sir.
position, isn't it?
Yes,
That
sir.
means if x is equals
And
to
moving
0, if
towards.
I'm writing the equation, see here from this equation, if I'm writing this condition, so now take x is equals to 0 and substitute in this equation. So it is a into your sine. This one is your omega into t value is nothing but 0 plus of your phi. Can I write like this? Isn't it?
Yes,
So
sir.
this will become for me how much? 0 part inflation. So this will become for me sine of your phi. Sine phi will be equal to 0 because 0 divided by
0.
anything will be again 0. So sine phi will be
Yes, sir.
coming how much for me, better? Because omega into 0 is nothing but 0. Remaining is nothing but
Yes,
of
sir.
your sine phi. So
Fine.
sine phi is becoming how much for me? 0. That means phi value is equal to how much, beta? Phi value is equal to how much for me? Initial phase will be equal to how much? For what value of phi it is becoming
0.
0? 0. అంతే కదా?
Yes, sir.
Sin 0
Sine
is
0
0.
is. Yes,
అంతేనా?
sir. Yes,
పక్కా?
sir.
So phase
Yes, sir.
value is becoming how much for me right now here? 0. Phase value is becoming for me 0. So that means x
0.
value will become how much for me? Phi value if I'm taking 0, x is equals to your a into sine omega into t. So that will be your x position. So x of the particle will be equal to how much for me, or a into sine
A
omega t.
sine.
Because the particle is at the
Yes.
equilibrium position. At the equilibrium position means there is no position of your x coordinate. So x coordinate, if it is becoming 0 at t is equal to 0, then phi value is how much for me? 0. That means x will be equal to how much for me? A into sine of your omega into t. Is that clear?
Yes, sir. Yes, sir.
If again t is equal to 0, the particle is at your positive extreme, na beta? T is equals to 0. Sine phi value if I'm taking
Yes.
is equals to your 1 part inflation. Then phi value will be equal to how much for me? Maximum displacement. So that means if I'm writing this
Yes.
equation, let's see here. If at t is equals to 0, particle is at positive extreme కాడ ఉంది అనుకుందాం. If the particle is, if at t is equal to 0, the particle is at your positive extreme position. Positive extreme position. What do you mean by that one? That means at t is equal to 0, I'm not here. At t is equal to 0, where I am? At the positive extreme.
Extreme positive.
Isn't it? That
Right.
means x is it x is there x 0 here? No, Gada. Positive extreme
No,
means
sir.
from mean
It's
position, x value is equal to how much for me? A.
A.
Means somewhere here, isn't it?
Yes, sir.
So right now it is the 0. If the particle is at your positive extreme position, that means x is equals to your how much beta? That means x is equals to at your positive
A.
extreme. అవునా కదా? So
Yes.
if the particle is at a positive extreme ante, if I'm using the equation x is equals to your a into your sine omega into t plus of your phi. So what is the value of t? T value is 0. So you substitute that value here right now here. So if I'm substituting that value of your a value is equals to 0 part, what I'll be getting right now? See here right now, x is equals to your a. This one is also your a into your sine omega into t value is 0 plus of your phi. Isn't it? So what I'm getting, this
Yes,
a
sir.
will get cancelled. So this will be equal to your sine of your phi. So
Sine.
sine phi value is how much I'm getting? 1.
1. Yes.
So sine phi value is equals to 1 means what is the value of your
90,
phi?
sir.
90. That is nothing but of
90.
your pi by 2. That
Right.
means at your
Yes.
angle, if the phase angle is at your pi by 2, then the particle is at your positive extreme position. That means how do you write the equation
Yes.
beta? X will be equal to how much at a time? X is equals to a into your sine omega t plus phi value is how much? Pi by
1.
2. Okay,
Yes, sir.
this is the condition. Or else I can write sine omega t plus phi can be written as of your cos. So x is equals to your a into your cos of your omega into t. In this chapter, we need to have a lot of trigonometric understanding, but otherwise doing the problems will become
Yes,
a
sir.
very difficult. So please try to go through my basic mathematics lectures on YouTube. So try to complete your trigonometry and how do you convert the angles 360 degrees, 270 degrees and 120 degrees. How do you take the angles? So please try to revise that one by going in a faster mode right now. Okay, na? So sine of your
Yes.
omega t plus pi by 2 can be written as of your what? X is equal to your a into your cos of your omega t. That means the sine form and the cosine form of your equation I already given you. Sine form of an equation is how much for me? X is equal to a into sine omega t, and cos form of an equation is x is equal to your a into your cos of your omega into t. Is that clear? Is
Yes,
that
sir.
clear? So we got the sine function of your equation and we also got the cos function of your
Cos 1.
equation. Okay, so the particle when it is executing SHM of an amplitude A and angular frequency in omega, O should always be your position of your equilibrium. Is it clear, beta? Is it
Yes.
clear?
Yes, sir.
This one you see. If the particle is about this mean position, and this is your point A, and this is your point B, and this is your mean position, that is nothing but O. From here to here, what is this distance, beta? This is your amplitude. If the video is getting half beta, you just join for another 5-10 minutes. I'll try to complete this one. Okay, na?
Okay. Yes, sir.
From mean to extreme position, the distance is known as amplitude beta. From here to here also the extreme position. That means at the equilibrium position, at A, at O, right here,
Yes,
at
sir.
equilibrium position. What do you mean by equilibrium position, beta? Which
0.
position?
Oh,
Yeah, at
the center.
equilibrium position. At equilibrium position means at your origin. That is nothing but of your O. What is velocity, beta? Velocity is maximum. Velocity is maximum. Just now we got see here. At x is
Yes,
equal
yes,
to
now.
0. Velocity is your maximum. V is equal to your a omega part of relation, but not 0. So
Yes,
velocity is of your maximum and is equal to V is equals to omega under root of your a square minus of your x square. Okay. Now see, at x is
yes,
equals to 0. At x is equal to 0. Keep x is equal to 0 in this one. So what will be getting? V will be maximum. So V max will be equal to your how much beta? A into your omega. Achinda.
yes, sir. Yes, sir.
Now at extreme position. At extreme position.
V will be 0, sir.
Yeah, at extreme position, whether it may be positive extreme or negative extreme, at your A or your B. So x will be equal to either positive A or negative A. That means velocity will
Yes,
become how much for me here? If x is becoming for me a square plus a square minus a square will become 0. So velocity of the particle is 0 at the
0.
extreme position. These are the things which you should always remember, beta. Is it clear?
Yes,
Chalo.
sir.
One more condition. If I'm talking about your equilibrium position, beta, at equilibrium position, wo acceleration or the force is zero, isn't it? So for example, if I'm taking this given condition right now, this is your given condition, this is your origin O, this is your A, and this is your B. Okay, so at equilibrium position, at equilibrium, that means at O, acceleration or force is zero. Because when I'm using a word called equilibrium, means net force acting on the system is how much for me? Zero. So what is an acceleration formula? A is equals to minus of omega square into your x. That means at x is equals to zero, acceleration is zero. So if acceleration is zero, so obviously F net will be equal to how much for me? Zero, because it is mass into acceleration. So net force acting on that particle is also becoming for me zero. Is that clear? At extreme position, now can you tell me at extreme position is what is happening? At your extreme position, magnitude of the acceleration is maximum, and it is always directed towards the center. At extreme position,